Welcome back everyone. In this video we will be unboxing and setting up the Creality CR-10 V2 3D printer. This is the upgraded version of the popular CR-10. Links can be found in the description. These are the key differences between the original and the V2. There is also a V3, which includes the direct drive extruder. Time to open the box. Seems to be well packaged. First thing we find is the manual. Going through it, it is clear and well laid out. Next we remove the top foam. It is very thick and sturdy, which help protect the parts. Now we get the first look inside the box. It is well packed with the thick foam all around. The first part to come out is the base frame and heat bed. This is pre-assembled. Underneath we find the cables that will need connecting. The connectors for the motors. And the power cables for the heat and the motors. Thick rubber feet are also fitted to the base frame. Next in the box, a sample spool of PLA. 200 grams worth. Then a box of accessories. Looks like one of the bed leveling wheels have fallen off. It can easily be screwed back on. Next is the set of pull rods. The controller box. This houses the brains and the power supply. Now we remove the excess foam. And take out the rest of the printer. This includes the assembled extruder assembly, the X carriage. And the vertical printer frame assembly. A look at the extruder assembly. And the vertical Z-axis motors. This is a look at all of the unpacked parts. In the accessory box we have bag with some tools, the Z-end stop switch, and some fitting bolts, the power cable, spool holder assembly, spool holder bracket, some spare components and a memory card, some extra bout and tubing, a scraper to help get prints off the print bed, and more fitting bolts. We'll reattach the leveling wheel. It just screws back on. Now we need the bag with the Z-end stop and fitting bolts. Time to fit the two frames together. First we need to hand turn the threaded rods. To lower the X carriage, make sure to turn both rods simultaneously. Next carefully rest both frames on their side. Using the M5 by 25mm bolts, push them up through the bottom of the base frame into the holes in the gantry frame. Then screw them on tightly. Next we assemble the pull rods. There are 4 of these sections, 2 for each side. We also need the other bag of components. The rod sections are held together with the M6 by 40mm screws. Just screw half of the screw in one end of one of the sections of rod. Then screw another section of rod into the screw. And screw the whole lot together tightly. Then get one of the M6 by 35mm eyelet bolts and screw an M6 nut onto it. And then this is screwed into the pullrod assembly. We repeat this for the other eyelet bolt and screw it into the other end of the pullrod assembly. This whole procedure is now repeated for the assembly of the other pullrod as well. Next we need to replace the end caps on the frame base with the ones with the holes in them found in the bag. The original ones just snap off. And the replacements just clip into place. Next we need to fit the L pull rod connector. We need the M5 screws for this. And the M5 T-nuts. These are fitted to the L connector like so. We need 2 sets of nuts and bolts per connector. The L connectors now get fitted onto the gantry frame. Align the T-nuts so they fit into the slots in the frame. Slide the L connector into position. Then tighten the screws. And repeat for the other L connector. Now to install the pull rods into the frame. Push an M5 by 12mm screw into the eyelet. And loosely screw it into the L connector for now. Now we need to adjust the bolts so the holes line up with the holes in the frame. Once lined up, screw into place with an M5 by 12mm screw. Then tighten the top screw as well. Then tighten the bolts to the rods. Then repeat for the other pull rod. This now completes the frame assembly. Now to assemble the spool holder. It just attaches to the controller box. First remove the nut off the end of the holder bar. Then we need the holder arm. And attach it to the controller box with the thumb screws. There are 2 holes in the top of the controller box they go into. Then attach the holder to the arm. Next is the installation of the Z-end stop switch. It fits to the left side of the printer frame. The holes are located to the bottom of the gantry frame, as highlighted. It screws in with 2 M4 by 16mm cup head screws. All the cables are positioned and labeled up accordingly. Just plug them into the relevant connectors. For the Z-end stop connector, it's easier to plug the cable in first, then attach the switch onto the frame.
Nope.
Wet carriage motor comes already connected. Next we connect the controller box to the printer.
Wow.
The cable from the printer goes into the round socket in the back of the box. It will only go in one way around, then it just screws securely into place. There are 2 cables coming out of the controller box. They have different size plugs, so can it be connected wrongly. The small one plugs into the bottom connector of the printer. and the larger one plugs into the connector in the X carriage. And that completes the cabling of the printer. This is how the completed printer looks. This is the filament runout sensor. An all-metal extruder assembly. A redesigned hot end cover and part cooling duct. A glass heated print bed. With texturing so the prints will stick better to the bed. Now we powered the printer up. So far so good, no errors. Now we home the printer. Next we need to disable the motors to perform the manual bed leveling. First make sure the X carriage is level. There are many ways to do this. You just need to make sure the height on both sides of the carriage is the same. The actual height does not matter, as long as the hot end is just above the bed surface. And the height on both sides of the carriage is the same. Just turn the lead screws on the Y-axis motors until everything is level. Next, home the printer again. Then disable the motors again. Now move the hot end to a corner. Slide some paper between the bed and the hot end. And adjust the leveling wheel until you feel a bit of drag on the paper. Move to the next corner and repeat. You will need to do this multiple times on each corner, until all the corners feel about equal. First we need to load up the filament. Push the end of the filament through the runout sensor. Then squeeze the extruder tension arm. And keep feeding the filament through until it can't be fed any further. Now we'll just use one of the demo models from the included memory card. As the filament heats up, some will ooze out from the hot end. This is normal, and means the filament is loaded correctly. This excess can just be pulled off. And now the print begins. The first layer seems to be going down nicely. This is a test to see how the power loss and resume function works. As the printer is working, we'll just pull out the power cable. Power has been cut. And printing has stopped. Now we'll plug the printer back in. The printer has detected a power cut and asking to resume. Click on Resume. The printer is heating up again. It purges a bit of filament. And carries on from where it stopped. Looks like the resume function works very well. Now we'll let the print finish. Let's have a look at the finished print. With a bit of persuasion, it comes off the bed. Let's have a closer look. It was printed using a 0.3mm layer height. A nice smooth finish all around. This is where we tested the power cut function. All in all, a good looking print. And this was without any tweaking of the settings. This is an easy to build and set up printer. It was built and up and running in about an hour. And seems to work well right out of the box. I think it makes a good printer for beginners and pros alike. With a great online community for information and support, I do recommend this printer. Thanks for watching. If you like this video, please hit like and subscribe for more content, and we'll see you in the next video.